A student has designed an experiment to find out the spring constant K of a spring attached to a ball launcher. He placed the ball launcher in horizontal table and connected it to a frictionless curved ramp as shown in the figure. The student compressed the spring by a distance x from its natural length and placed a ball of mass M as shown in the figure. He subsequently ejected the ball by releasing the spring so that the ball climbs along the ramp to a maximum vertical height h without rolling. To measure the vertical height h, student has used a properly calibrated scale marked along the ramp as shown in the figure. Write down the least count of the scale marked on the ramp. We can observe the magnified part of the scale in the ramp. It is calibrated with a millimeter scale. Therefore, least count of the scale is 1 millimeter, or you can write 0.1 centimeter. Then part B, when the spring is compressed by a distance x, write down an expression for the stored energy E in the springs in terms of K and x. We know that energy stored in a spring is half kx squared. Ke squared, we are using E for the extension, but now they have given x as the compression. Therefore, we have to use x for the E value. Part C, write down an expression for the gravitational potential energy U that the ball will gain when it reaches the height h after spring is released. We can write potential energy mgh. Then part D, using your expression in B and C, obtain an expression for the height h in terms of mx, k and acceleration due to gravity g. We can equal two types of energy because of energy stored in the spring is the given energy to the ball. First of all, that energy will convert to kinetic energy of ball. After that, it will move to a height h, and at the maximum height, that kinetic energy is completely converted into potential energy. Then we can write mgh equals half kx squared. We have to subject h. Then h is kx squared divided by 2 mg. Part E, name the principle that you have used to obtain the expression in part D. Conservation of energy. We have to just name the principle. They have not asked to write the principle. We have to name the principle. Then we can write the name of principle. Then part F, to find the spring constant K, the student has plotted the graph h versus x squared as shown in the figure. Part 1, the teacher says that graph is unsatisfactory. What do you think it is unsatisfactory? They have given corresponding plotted points in the graph. It is like this. It is in a small region. Therefore, we can write points are not spreaded. We have to use spreaded points to obtain final result with a high accuracy. Then part 2, what measure would you take in this experiment to improve the graph? What measure would you take in this experiment to improve the graph? We can choose X so that we can obtain spreaded points. Then part G, if the gradient obtained from the graph is 200 per meter and the value capital M is 0.125, find the spring constant. By using this equation, we can get H is K divided by 2mg. It is not simple M, it is capital M. We have to use capital M for mass. 2mg times x squared. It is in the form y equals mx. Then we can get gradient of the drawn graph is this term. Then we can write gradient should be equals to k divided by 2mg, and they have given value of gradient is 200 in SI unit. We have to find k, 2 into mass of given ball is given as 0.125 into G10 equals 200. 2 times 0.125, 0.25 into 10, 2.5. K value is 2.5 times 200. 2 zeros, 2 into 25, 50. We have to separate one decimal place. Then we can obtain 50 is the answer in Newton per meter. Then part H. In this experiment, the student measures the compression X and corresponding height H. Which one of these two measurements has to be taken more accurately than the other? What is the reason for this measurement X? We have to measure X with a high accuracy. There are two main reasons for that. First one is X is a small length. When measuring a small length, if there is an error, the effect is greater than a large reading. Second reason, it is the best reason for this one because of we can't decide. We can arrange the practical such that X value is a proper length. X value with the proper length. Therefore, best reason is there is a second power for H value. Therefore, if there is an error in X reading, its effect is greater than simple H reading because of there is a higher power for the X in expression, X in equation. Then we can get measurement X is X should be high accurate. We have to measure X with high accuracy. Then we can write reason. There is a second power for X. Therefore, when calculating the effect of error of X is greater than effect of error of H.